and we're going to be exploring inverses. And I know Frank did a really good job teaching you how to find the inverse, but we're kind of looking at more what an inverse actually is. A lot of what I care about in pre-calc and what I care about in POLs is not can you do the quadratic formula or can you find the inverse. It's more why does this process work the way it does? Why is it meaningful? Why is it useful for us? CPM's definition of an inverse is this: undoing a mathematical equation. That's one way of thinking of it. I'm going to use the word process just because we're thinking about pushing that through that function machine. 3 to 7 and 7 to 3, right? Actually, what did you guys get for the first pattern? 3 to 7, it was 2x plus 1, right? And then the inverse, I'll just write this in here. What was the inverse? How did you get from 7 to 3? Yeah, Carl? Remember getting x divided by 2 minus 1? Did you guys get the same thing?
Yes.
Somebody get something different? Subtle difference here, Cameron? Perfect. Are those two different? We're calling it opposite. So the two things that need to happen, you're going to do the inverse operation. You can think of this as adding versus subtracting, or multiplying versus dividing, or exponents versus logs. They undo each other. There's a second thing that happens, though. Not only are you doing the inverse operation, the order, right? Here you multiply then add. Here we subtract then divide. So you're actually doing, I was saying this to some of you, we're actually doing SADMAP. You're doing the order of operations backwards. And doesn't this make sense if you think about that function machine? Aren't we going back through the machine the other way? Yeah, so it's a good analogy. All right, now, right now this might still be a bit abstract, but once you actually do the process on this, and you see it, it'll be like, oh, this totally makes sense now. So Frank did a good job of teaching you what this means. F of negative 1 of x does not mean 1 over f of x. It means the inverse. So when you see this, make sure you know that I'm referring to the inverse. So here's your example. Find. You got it. And this is how I'll ask you on a test. So if you don't know what this notation means, it might be a bit challenging. Find the inverse. So here's your first one we'll look at. 3x cubed minus 5.
Can you say what you're saying?
Yeah, what do we rewrite? How do we rewrite this?
So f negative to the negative first power x equals.
Well, not even that yet. What would I change f of x to? We're going to get to that. Correct? Yeah, it's our output. Y equals 3x cubed minus 5. So we rewrite, and then what's my second step? Switch?
The x and y.
X and y, yeah. And you guys have learned this, right? So it might help to actually write this over on the side. We switch x and y, and that's why we're rewriting for y. So now we have x equals 3y cubed minus 5. The rest is algebra, but what's our goal? What are we trying to do with this equation?
Get y by 4.
Isolate y. So from here on out, you're trying to isolate y. Now, before you guys start working on this, here's what I want you to do. Anthony, what's my first move here? Okay. Joshua, what's my first move?
First move is add 5.
You got it. Go ahead, add 5 first. All right, we have x plus 5 equals 3y cubed. All right, Sabrina, what's my next move?
Divide by 3.
Divide by 3. Good. Divide everything by 3. Now we have x plus 5 over 3 equals y cubed. And then how do I take care of this cubed? Cube root it. Nice. Take the cube root of each side. And here's how I want you to write your final equation. We switched to y, but our original function's f. So you're going to write the inverse of f of x equals the cube root of x plus 5 divided by 3. Go ahead and box this. And make sure that all of x plus 5 is being cube rooted. We'll do this when g of x equals square root of 2x plus 5. And find the inverse of that. I would definitely talk to... Alright, you guys can look at my work up here. Some of